It's my great pleasure to be here in Budapest again. In 2019, I've been the last time in the personal presentation, and I would like to talk about metamorphic testing. This little illustration should show you what the Latin word metamorphism means. It's a transformation of shape. So what does it have to do with testing? Well, we're talking about transforming test cases into different test cases. So when we're performing dynamic testing, we feed inputs to a test object and get actual results. And in order to decide whether they pass or fail, we need expected results. So the procedure that delivers us expected results for some inputs is called the test oracle. This is another Latin word and very well illustrated by this beautiful painting from ancient Greece, where the lovely lady is reading her tablet and telling the expected results to the brave tester. But we're not always lucky to have a complete test oracle which predicts the expected results for any input, right? That's sometimes we have a legacy system or another means, but usually we have a problem with it. And the bigger the data we use, the bigger the problem. So back in 1982, 40 years ago, the lady Ellen Wyuker, who is a very well-known software engineer, has published an article that she entitled on testing non-testable programs, and she called them non-testable if they are lacking an oracle. And she explained that there are three main approaches to resolve this problem. The first one is what you usually do in manual testing. You restrict your testing to those simple inputs for which you can predict the results. Right? That's what I do also. For instance, for calculating a percentage, you take it as an input 100, and then you will predict what the percentage will be. But that has a drawback because it's often not effective, so not catching the real intricate bugs. Another approach that she explained was to develop several solutions. So to develop what you might call a pseudo-oracle. So a new program which is only there to generate the expected results. This is, of course, very expensive, and so used in safety-critical systems where the impact would be really large and it's worth investing so much. And the third one was called differently by her. She called it a partial oracle. Well, when you compare not the whole actual results, but just some properties, like some values being positive or some data larger, bigger than other data. So this can involve inputs and outputs of a test case, but stays within a test case. And she concluded her article with saying that it's a major task for software engineering to develop new ways of dealing with the oracle problem. But for many years, nothing happened. No new method came up. And recently, I came across metamorphic testing, which is exactly such an approach, a new approach, which is based on consistency of different test cases. So different similar test cases with similar inputs should yield similar outputs. And let me explain this by an own example that I practiced in my domain. So I'm at ISTQB responsible for the glossary of testing terms, and this glossary is stored in a database. And we don't just store the testing terms, but we also have a list, a table with a list of ISTQB syllabi, because the users want to know which term is used in which syllabus. And if you've done some ISTQB certification, you will certainly remember that in the syllabi, in the beginning of each chapter, there is a list of keywords. So the most important relevant testing terms in that chapter. And our glossary application can also show you which are keywords and which are not. So whenever ISTQB releases a syllabus, this was the case with the foundation level version 3.1 in this case, then I run a program, the ISTQB glossary checker, which scans the syllabus for glossary terms. So it reads the glossary database, scans it, and fills in the relational table of terms used and whether they are keywords or not. This program has been developed by 2 students for German testing board, and I don't trust it. The students are gone. I can't change it, but the program is not really reliable. So what do I have to do after running it? I have to test it. So let's try it with metamorphic testing. In metamorphic testing, you first run a so-called source test case. The source test case, in this case, was just running a simple search in our glossary application, searching for a string. I've chosen here test. Of course, I've chosen several inputs to test it, but test was the best one. And then you obtain a result which shows a list of 226 terms, and we have 590 in total, at least at that time. We had 590, so we don't have an oracle, we don't have the means to check it, but never mind. This is not what I wanted to test, so we just assume that the source case, test case passed. We cannot prove it, but we assume it passed. Now we transform it in a metamorphic relation, and the metamorphic relation would be, we notice that we can filter the search, the same text search, for terms used in the foundation level. This is what's interesting now. And the metamorphic relation says that the resulting list should be a subset of the previous list, right? So very simple. And we run it, and we get an actual result of 112 terms. And I run a comparator, and I prove that there is nothing which was not in the previous list. So this looks also very nice. Okay, so the metamorphic relation 1 has been verified. It's confirmed, it passed. But now I turn this test case into the source test case of the next relation, because I notice that we have additional filter criteria for filtering for keywords only or non-keywords only. And the second metamorphic relationship would be that if we add those filters, then the keywords only and non-keywords only must partition the original set. So we have to get 2 subsets which are complementary and disjoint, right? So let's run them. And we see the results. We have on the top the keywords, acceptance testing, alpha testing. If you're familiar with the syllabi, it sounds reasonable. We have test accessibility, decision testing. These are not keywords in the foundation. That sounds all reasonable, but wait a minute. We have 64 plus 42, and we had 112 before. So 6 terms are missing, right? So metamorphic relation 2 failed. And this is the test result. The metamorphic relation 2 is not fulfilled by our application. We can't say which of the 3 test cases failed. Actually, I went into debugging and found out that the 6 were missing in the keywords, but that's a different story. I don't have the time to explain it now. So this is how metamorphic testing works. Now let's look at the history. It has been introduced in 1998 by a group of Chinese researchers at the Hong Kong University by Chen and his colleagues. And they published it in the technical reports of the university, which I guess no one of you is regularly reading, neither do I. But they went on conferences and talked about it and contacted colleagues, advertised their method, and it slowly, by the years, became known. And people started to apply it in practice, and it was proved in practice. In 2018, a group of Spanish researchers from the Sevilla University conducted a survey of publications, and they found out that there were 84 case studies published, and this diagram shows you the distribution of application domains. I would say artificial intelligence is missing there. Web services is a good one, and some others. I don't want to go into details. And you can find this, and the article that I would recommend if you want to get more involved in this is in the IEEE Software magazine, which I hope some of you are reading, in 2020, where all the grand authors of this method joined and published a survey of metamorphic testing, including Chen and Segura, the leader of this survey. So only 1 year later, it has been already included in the new version of the ISO 29119 standard for test techniques. The part 4 is about test techniques. So it's not so exotic anymore. And we didn't include it in the ISTQB Advanced Test Analyst, which is my responsibility, because we didn't issue a new version or a major revision yet. But the new ISTQB artificial intelligence testing is dealing with it, because it is a very important test technique, one of the most important test techniques actually for testing artificial intelligence-based systems. So this is the state. Let me show you 4 little examples from the case studies published. And the oldest one I want to talk about was in 2015 at the NASA Data Access Toolkit. So the NASA is collecting so-called telemetry data. So all their missions are collecting all the metrics in the sensors, and they transmit it to the ground system, and they have a huge database, as you can imagine. And if you develop a new mission, then you have to study these telemetrics data. And it is crucial to have accurate data in it, because that's what the new missions are based on. And so these guys, a group from the American Fraunhofer Institute, they were in charge of acceptance testing, and they used metamorphic testing in combination with model-based testing and other techniques in an agile development of this system. So the oracle problem is, can you tell whether these queries in the huge database are delivering accurate results or not? And they found really a large number of defects by metamorphic testing. So they transformed the queries into equivalent queries, which should yield the same result sets, and the result sets were often different. So this was one of the success stories. The next one, 1 year later, is a group of Chinese researchers have tested the most popular search engines. And that has, of course, a major oracle problem, because the search database is constantly changing and you cannot predict. And how do you test it for reliability? They ran lots of test data in metamorphic testing over a long period of time, and they found out that none of them is 100% reliable. Of course, as you would think, in English, Google is more reliable than Baidu, and in Chinese, Baidu is more reliable than Google. And you can find metamorphic relations like running a query, then filtering or restricting the query to some property of some top results, like the URL domain of the top result. So you get a top result from Australia, then you run the query just for Australian sites, and you find different results. So this was another success story. 1 year later, a group of researchers have tested drone artificial intelligence controllers. They were not military drones, but peaceful, the parcel delivery drones, flying from a base station to a destination, and had to avoid the obstacles. And the problem is that you cannot exactly predict the routes. They have to fly safely. And let me show you one example here. I don't want to go into the details, but in this example, you have a flight to, the source test case is a flight to the north. This is already a follow-up test case which has been rotated by 25 degrees. But in the source test case, you fly to the north to a destination, and you have an obstacle in the middle and two on both sides. And the drone is avoiding the obstacle by turning right around the obstacle. When they rotated it more than 25 degrees, 27 degrees, suddenly the drone avoided the obstacle from the left side. So they started reflecting when does this change happen, and they found really the angle at which the drone flew directly into the obstacle and crashed. So this is one of the examples in this case study. A next one about the correctness of autonomous driving, and we just had this topic before. I don't want to go into the details because the time is running out, but they also tested a top-performing deep neural network-based artificial intelligence vehicle control systems, self-driving systems, and they published in the internet on GitHub their failures. And I highly recommend you to look at these pictures before you onboard a self-driving vehicle. So this is one case when you're driving in a very uncritical situation, driving a country road into a left curve with some oncoming traffic, and then you add to this picture some rain falling on the picture, right, on the video. And the self-driving system takes the left turn too early and drives you directly into the oncoming traffic. So it's really scary to see these examples. Okay, having had fun with failures, just a short recall of what we presented with my friend Tamás Horváth 2 years ago at HUSTEF. These are the work products of test development. So you start with test conditions, and I just want to say where in metamorphic testing the entities are. So we start out with the specification as test basis, because you have to know the specification to derive your metamorphic relations. Then the test conditions that you want to cover by testing are the metamorphic relations. But of course, it's not enough to run one low-level test case for one metamorphic relation. You usually run many of them. The test cases are a little bit peculiar because we don't have an expected result per test case. We have just the comparison between several test cases, but the rest goes smoothly to test procedures, test suites, and so on. So it's, I would call it a test technique, even though it has a small difference between the classical ones. Finally, the test analysis is a very important part, and it determines actually how effective you will be in detecting the defects with metamorphic testing. It's essentially creative activity, as it always. So analysis is the human creative activity, and you need for that the knowledge of the application domain. You need to be skilled in functional decomposition. You need to be able to write it down in a formal manner, the metamorphic relations, such that you can feed it into your model-based testing machine and run everything automatically. And it has two different approaches. I don't want to go into those details, but one interesting aspect is whether you have end criteria. And the end criteria from practice are usually either you test as long, you feed as long inputs as you still find new defects, or a white box coverage like neuron coverage in artificial intelligence. So in conclusion, I think that metamorphic testing has proven its value. I'm really decided to include in the new syllabus this new technique. It's relatively new and it's integrating very well with model-based testing, with actually continuous testing, so automating everything. Thank you very much.
Beautiful time management. So far we have 3 questions. The first one I think is my favorite question ever. Your shirt says, I love certified testers. I have 10 years of experience, still don't care about any certification. Will you still love me? Faisal. Amazing, you're my favorite one, really. So do you love him?
I love skilled testers. I hate stupid testers.
But so he doesn't need to be certified.
No, he doesn't need to be certified. He needs to be intelligent. That's
okay. According to your question, you definitely are. Thank you very much. Okay. In which cases would you recommend one of the other 3 methods instead of metamorphic testing?
Well, restricting yourself to the inputs that you can predict is the method of choice in IT applications, in usual IT applications. So if you can have the specification as a test oracle, can use it to a certain extent, not always, that's okay. As I mentioned, developing an automated test oracle, a second program, is really costly, and that's where I think only safety-critical systems play a role. And the property-based testing is getting more popular. And I don't know if you've seen the talk in Barcelona, I don't know in which year, about don't write test cases, generate them. So this is something that you can generate. And that's a very nice technique. I would recommend that one for any case.
Okay, this sounds like testing. The tests are needed as well. Can metamorphic testing start with adding altered tests to the existing ones?
I have to understand that. Altered means transformed, changed in a metamorphic way. Yeah. Then, so the most essential. The most essential information here is that you need a metamorphic relation. You need to know what happens if you alter a test case. How will the inputs and outputs change? And if you have that, you're into metamorphic testing.